Hi, everyone. Really happy to be here. Thanks for sticking with it for this last session of the day. Okay, so in this presentation, you'll see that the format is basically kind of mistake area and then solutions for that. And so I have a lot of links in here, more than 60. So if you want to check any of these links, go ahead and scan this QR code or go to bit.ly/RC10M. The slide deck is online already, and you can find all the links there. So yeah, and before I get into it really briefly, RailsConf has been a big part of my career. My first one was in 2010 back in Baltimore. And in the last few years, I've been able to present, which has been a real honor. And so I did want to, if you wouldn't all mind, you might have done this before today outside of this morning session, but we could all just do a quick round of applause to thank all the organizers and attendees that have made RailsConf happen. We'll miss you, RailsConf. Okay, so let's get into it. So we're going to look at costly database mistakes. And some of these are going to be direct costs that are sort of obvious. You might over-provision your instance to handle certain high load periods. Some will be more indirect costs, like bad user experience that leads to customers downgrading or leaving your platform, or maybe an excessive amount of time spent by devs triaging an incident or resolving it, that sort of thing. So I'm going to have these little bubbles in the bottom right that will show some of the costs for each of the problem areas. So we're going to look at 10 items in 3 categories. The forming category would be kind of intentionally attacking your database performance challenges related to improving your agility, performance, reducing latency, that sort of thing. And then scaling and optimizing, those are probably more clear. And we'll go from 10 down to 1, and each of these have their own color, and then these costs are in the bottom right here. So far, so good? Good. Okay, so first up, mistake number 10. And we have to cook through these because I have a lot of content for 30 minutes. So I will talk at a reasonable clip. Apologies to non-native English speakers. Please watch it at 0.7x, 75x later on if that helps you, or watch it at 2x if I'm talking too slowly. Okay, so mistake 10 would be infrequent releases. As we know, we release most of our DDL changes, our schema or structural changes to our database through Rails migrations. So having an infrequent release process can really reduce your team's agility and ability to evolve your schema. So using something like Gitflow or a similar sort of legacy software delivery process, not using feature flags to decouple your releases from feature visibility, not tracking or using DevOps metrics in a metrics-based approach, and then performing DDL changes exclusively using Rails migrations. We'll look at one alternative to that briefly. So this can increase your cycle time and increase your time spent responding to and resolving incidents. So to fix that, I recommend trying to move towards trunk-based development if you're not already doing that, using feature flags to help decouple your releases from your feature availability. And there are teams out there using Rails that aren't doing trunk-based development. Last year's Rails survey, 20% of the respondents released multiple times per month. 2% of the respondents released multiple times per quarter. So that's pretty infrequent, and it's going to reduce that team's agility. Tracking DevOps metrics, a couple of frameworks, if you're not familiar, Dora and Space are 2 frameworks that have a few key metrics related to your team's ability to deliver software. The book Accelerate covers Dora, and Dora has a 2-minute quick check that is useful on teams to take and look at a few metrics. I'll show an example of that. As developers, we can help raise our test suite's coverage, increase its speed and its reliability. And then one other option you could look at if you are in this position now where you're not doing trunk-based development, I've released a new gem called Anchor Migrations, where the idea is to do SQL migrations that can still be safety linted using a tool called Squawk, which I'll show. And we can write non-blocking, idempotent DDL changes and then generate Rails migrations from that SQL to keep everything in sync. So on the top here is just showing Squawk briefly within Anchor Migrations using the lint command. So I've created a DDL that's creating an index but not using the concurrently keyword. This would be for Postgres. And Squawk is the SQL linting tool that I mentioned. So it's detected, hey, you should use concurrently here to avoid this being a blocking DDL operation. This is that Accelerate book I mentioned, and then here's a couple screenshots from the Dora 2-minute quick check, and it covers their 4 primary DevOps metrics: lead time, deployment frequency, change fail percentage, and failed deployment recovery time. Okay, so mistake number 9, database inexperience. So as Rails developers, we're usually working with Active Record, and we're working at the ORM layer, so we're dealing with object orientation, inheritance, classes, that sort of thing. And relational databases are quite different. You know, we have data access to think about, SQL, relations indexes, execution plans. So there's kind of this mismatch, and it is a different set of skills. So often teams might get stuck where they're not hiring database specialists or DBAs on their team. They're not using SQL and application code or BI types of code. They're not reading and using query execution plans as part of their designs, or using terms like cardinality, selectivity, and execution plan buffers from Postgres execution plans, for example. They might be adding indexes kind of haphazardly, or choosing schema designs that have poor performance. And this again can increase your server costs and increase your developer time. So to fix that, you can directly hire experience. You can look to hire database specialists, DBAs, and consultants. You can grow experience on your team with books and courses and conferences like this one, and communities. I'm particularly, I'm involved in the Postgres Slack community, and that's a good one that I'd recommend if you use Postgres. A specific tactic at companies that I've seen work well is to create a production clone, if you can afford that in your infrastructure budget, where you've got a similar sized instance and data to work with, and then you can really integrate that into your workflow and run all of your DDL changes there. And as you gain more experience, you can use these concepts of pages and buffers and selectivity and cardinality in your designs to help improve your designs and reduce latency in your queries. And you can learn to avoid performance unfriendly designs like random UUID primary keys. I just wrote a blog post on that that's linked up here. You can check out if you're interested. So you'll learn about row versions, and you can figure out which Spider-Man is the live Spider-Man and which one is the dead Spider-Man. You'll learn about fixed size pages where data and index entries are stored, and how dense or sparse your storage is and how that affects latency. Here are some books I recommend. These are Postgres books. So this is meant to be a talk that would cover MySQL and SQLite as well with Rails, although it's mostly, I've got more content in here related to Postgres. And then the last book is my own book, which I'd recommend if you aren't familiar with it. These other books are more Postgres oriented directly, and they're all great books. And then a couple of courses. Aaron Francis has produced a couple great video courses on Postgres and SQLite. And then Creston Jameson has produced a couple of great Postgres courses as well, including a couple free ones. And Ludicrous Speed is one that I went through and would recommend. Okay, so next up, I'm calling it speculative DB design. So this would be something like avoiding a beneficial database constraint today in your schema design based on speculation about your needs that you might have in the future or tomorrow. So you might doubt your ability to evolve the schema design in the future. You might not be using third normal form normalization by default. And then on the opposite side, you might be avoiding all forms of denormalization, where you want to gain an advantage on your query side at the cost of some data duplication. And so there are cases like multi-tenancy where that can be beneficial. So this could show up as data bugs and increased maintenance costs. So to fix that, I recommend trying to use all available constraints that are available in your database for improved consistency, referential integrity, and data quality. And I created this core acronym to represent a few different design principles for schema design, where the C is constraint driven, and I've got a blog post on that if you're curious. You can I recommend trying to create matching database constraints for your active record validations, doing things like matching your primary key and foreign key types. So there's a tool called database consistency. That's a Ruby gem, which I'll show that helps you achieve some of that. I recommend using data normalization practices by default, working to eliminate duplication, designing for today, but also anticipating growth in your data and query volume. And then I think denormalization is a useful tactic some of the time. For example, if you've got a multi-tenant app and you want to denormalize your tenant identifier column. So this is a SQL query that's just showing the number of foreign keys per table as a ratio. And this is useful if you just want to do a quick check on your own database for your usage of constraints. Here's a quick screenshot from that database consistency command line tool. It's got a lot of built-in checkers. It's a really nice tool. So in this case, it's checking that there's a foreign key constraint defined that matches a active record validation and that the foreign key and primary key data types are matching. Okay, next up is missing DB monitoring. So a lot of folks probably use APM tools with their applications, but they might have less monitoring and visibility on their database activity. And that could be both foreground client application activity and background processes. So not logging slow queries or collecting query statistics and execution plans, not using the buffers information in Postgres execution plans, spending time finding application source code for where SQL queries are generated, not monitoring critical background processes like auto vacuum. So again, these can increase your time spent triaging an incident and resolving an incident. So to fix that, I recommend logging and storing all source code line number locations for your queries. And you can do that using query logs in Rails. There's also a gem called marginalia. Query logs formats the annotations using the SQL commenter standard, which is nice. And if you enable that, you'll see it right away in your Rails log. And if you use Postgres, you can use those annotations in PG stat statements as well, which will capture normalized query statistics and then give you your comments to go back into your source code. I recommend collecting query execution plans and using those in your designs and your pull requests and that sort of thing, manually or automatically with the auto-explain extension in Postgres. Our goal is to reduce the buffers counts in our execution plans. So first we got to take a look at how many buffers are being used, whether they're coming from the buffer cache or outside of the buffer cache. Our goal is to reduce latency. And there's some other database observability tools here besides PG stat statements, PG Hero, PG Analyze, which is a sponsor of RailsConf. PG Badger is a Postgres log analysis tool. And then I have a few more tools here for MySQL and SQLite listed. So here's an example, if you haven't used those query logs, of what that could look like. So here we see the controller action and application name for where this query was generated. The query text is just above the yellow highlighted area. And then more usefully, we have the source location. So we can see the model where the query was generated, the line number, and the method name. Okay, next up, ORM pitfalls. So the ORM is what we're likely using for most of our applications queries, but there can be some pitfalls. So performing unnecessary or costly ORM queries like count queries or order by that aren't really needed by the application, but are part of what is being generated. Using non-scalable query patterns like the huge in lists. I wrote a blog post about that, which can happen either through direct mechanisms or through eager loading. So check that out if you're curious. Not restricting column access, so all of your queries are select star queries. We'll talk about that a little bit. Using the pagination that's comes by default with the ORM, and then not using some of the caches that are available with the ORM with Active Record. So this could result in over-provisioned instances needing to scale up further than what's needed, and inefficient queries. So to fix that, I recommend, and this would be more for a mature application. It's been around for a while. It's likely that there are some redundant or unnecessary queries. So I wrote a post called Putting Your App on a SQL Query Diet that is intended to help folks go and find queries and study and make sure that they're actually needed or useful. If not, we can remove those. We can try to limit our columns to what's needed using select and pluck in Active Record, and that can help us with better use of our indexes, particularly multi-column indexes. If we do have the in lists types of queries, and if we have big tables and we're working with hundreds or thousands of values in these in clauses, it's likely that you're going to see bad performance from those types of queries. So those are opportunities to restructure those, and you've got a few options. You might be able to restructure into a join, or use a values clause, or use the any operator with an array in Postgres. For pagination, you could look at endless, or also called key set pagination, and the pagi gem is one that I've used that can help you set that up. And then with Active Record, we have a lot of different cache options. We have the prepared statement cache if you're using prepared statements. And that allows, prepared statements allow us to skip the repeated parsing and planning stage as the query arrives in the database engine. And we can use the counter cache to avoid unnecessary count queries. We can use the size method over count and length if we have a loaded association to count how many items are in it. So on the top here is, this is actually from the Rails guides. So we see that there's a book model, and then there's an eager load of the author association. And that's going to generate in the next block these two SQL queries, one for the books table, one for the authors table with this in clause. And this is a small set of values, so this isn't going to be a performance problem, but this can grow into hundreds or thousands of values. And that's where you run into issues. So we can restructure that. Here's one example in Postgres that uses the any and array structure to restructure that query and give us an equivalent result. All right, so mistake 5, I'm calling DDL fear. So this is something I've seen on teams where a team might create kind of a code workaround to avoid evolving the schema and doing a data backfill. Data backfills can often be quite intensive, but a mistake here might be avoiding it when it might be a better design long-term. Using blocking DDL operations due to not understanding locks and how operations that are requiring the same lock get queued up and that sort of thing. We'll look at some ways to get a better understanding of that. Not linting DDL migrations for safety or for non-blocking designs. Not practicing big DDL changes on like a production DB clone like we discussed earlier. And not automatically canceling contending DDL operations. And so we're going to look at the lock timeout, which exists in all of the supported database engines. So again, this could be longer cycles, higher maintenance costs. So I recommend if you have that production clone, trying to run all of your DDL changes through that first, collecting timing, understanding what's locked while those are running. Using tools like strong migrations in Postgres or online migrations for MySQL, MariaDB, or Squawk for SQL helps us detect blocking or unsafe DDL changes. And then often those tools, particularly strong migrations and online migrations, will suggest safer alternatives to us. So we can perform those equivalent operations, but usually with multiple steps. And then there's other tactics like using the ignored columns feature in Rails to detach our code from the schema first, deploying that. Tactics like using an invalid check constraint before we add a not null constraint. There's a nice tool called pglocks.org that shows operations in which locks they acquire, whether they're table lock or whether they're exclusive locks or shared locks. And that's a Postgres specific tool. And then, I recommend trying to set a low lock timeout for any DDL changes. And if the lock that's needed can't be acquired, then we would retry that DDL change at a lower activity period. Okay, so mistake number 4, I'm calling excessive data access. So imagine you just got back from the grocery store, you've got like 8 grocery bags, and you can either bring them all in with like 4 bags on each arm, or you can make 2 trips of 4 bags each. So if you're a database, the second approach is gonna be better. We wanna try to work on small result sets. So a mistake here could be querying and retrieving huge sets of data, 10,000 plus rows, and doing that while the user is waiting. And this is usually a symptom of something that initially was fine, but now the application's 4 or 5 years old and it's no longer an acceptable amount of time. So it's taking multiple seconds to load data. So there could be ineffective filtering and indexing on low cardinality columns or columns with a small amount of unique values. Missing indexes on high cardinality columns or foreign keys, and missed opportunities for filtering and reducing our result set sizes. Not using advanced indexing strategies or index types, performing slow aggregate queries like sums and counts, making users wait, and not breaking up big tables using table partitioning, which we'll touch on briefly. So again, this could increase your server costs and worsen your user experience. So yeah, we want to try to work with small sets of data, and this is often going to involve taking a look at your existing queries and restructuring them, looking for additional opportunities to select fewer rows through extra filtering, select fewer columns, performing fewer joins. We can look for missing index opportunities on high cardinality columns. So I've got some queries that you can use to try that out, or we'll look briefly at the pganalyze-lint command line tool. It uses this extension called hypo-PG, or hypothetical indexes, basically, to try out different index opportunities and see what would result in a reduced latency. And then we want to try to use advanced index strategies like multi-column indexes, or in Postgres partial indexes, and then other index types besides B-tree like gin and gist. We want to, one option is to pre-calculate some of those aggregates as they become slow. So one option there is the roll-up gem, and I've got an example with the rideshare app that shows how to use that. It's like a kind of a generic mechanism to create different time-based roll-ups of calculations, so that then at query time they're very fast. We can also denormalize data from a bunch of different tables and create a materialized view, and we can manage that using the scenic gem in Ruby. For our huge tables, maybe 100 gigabytes or more, we can look at migrating those to partition tables to improve performance and maintenance. So here's a quick look at a command line tool called pganalyze-lint, and I'm running it on a rideshare app with the rideshare users table. And it found an opportunity for a missing index on the users table and the type column. All right, mistake number 3, missing data archival. So this is something I've seen in most of the consulting work I did. I think it's just more of a phenomenon of over time data is stored in the database, and what can happen is data exists and it's not queried. So storing a significant proportion of data in tables and indexes, and that's going to increase latency. So there's an opportunity there to archive that, which we'll look at. Capturing high growth data. Maybe you've used one of these gems before: public activity, paper trail, audited, Ahoy, and not archiving any of that data once it's no longer needed in the database. It could be first-party data that your application creates, but it's from customers that have left your platform, features that you've retired, or soft-deleted data. Another thing a lot of teams do is perform massive delete operations, so they could work with lots of rows on big tables. And at least in Postgres, that's pretty resource intensive, so we'll look at an alternative there. Same sort of thing, this could increase your server costs unnecessarily to be able to handle high load, possibly even from a delete operation, and worsen user experience from increased latency due to just having more data that's not needed for querying purposes. So here's an example of a pattern. This is from pganalyze, where the reds are inserts, and then the big spikes of greens are delete operations that run in probably from a cron job. So I recommend trying to archive all data that's not regularly queried. I wrote up a post called copy, swap, drop, which is a tactic that I used with one client where essentially we create a cloned structure of the table and copy in a subset of the rows and then swap the table names around. We can also, if we know our data fits well for its high growth data and it would fit the characteristics of a partition table well, we can use partition friendly gems at the outset, or we can migrate our big tables to be partition tables and make any necessary Rails code changes. And as customers leave the platform, or we have soft deleted data or features that we've retired, we can archive that data from our application. I'm a fan of the open source tool called Coverband that tracks your code execution, and you can use that to help discover features that are no longer used that could be retired, and thus the data from them could be retired or archived. And for the massive delete operations, there's a possible benefit there to migrating that table data into a partition table and then moving to a detach operation of old partitions that are unneeded, which is much less resource intensive and can be done concurrently in Postgres as an alternative to doing delete operations. All right, last couple here, so thanks for hanging in there. So mistake number 2, missing database maintenance. So this one's a little bit more straightforward: running unsupported versions of Postgres, MySQL, or SQLite, not monitoring or fixing heavily fragmented tables or indexes, also referred to as bloat, but essentially unneeded objects in the database, or in this case, row data, and then row data that's captured in index entries as well. Leaving auto vacuum or other maintenance parameters untuned, just sort of in their stock configuration, and then not removing unneeded database objects. And in this case, objects is triggers and constraints and other things like that. So this could result in poor performance, security risks, or worsened user experiences. So anytime I run across tables or columns or constraints or indexes or functions, there's lots of things. I'm trying to remove them if they're no longer needed. So upgrade your database. Postgres, the Postgres community has this nice, one of the community members created this nice tool called Y Upgrade that shows your current version and your target version and all of the differences between them. That's really nice. I recommend tuning auto vacuum in Postgres for your workload. So in particular, look at your heavily updated and delete your tables where there's a lot of updates and deletes, and that's likely where you're going to want to add more resources for auto vacuum. We want to constantly prune and tune our indexes. So our indexes are designed to support our queries. So they should be used by one or more queries, and they should provide a meaningful reduction in latency by being scanned. So I've got a couple tools here that are useful to help you achieve that. Dropping any unneeded objects from the database. And then for heavily fragmented or bloated tables and indexes, we can rebuild those tables and remove that bloat from those no longer referenced row versions. And the same thing for indexes. In Postgres, we can reindex, and we can do that concurrently. And I spoke on the Maintainable podcast about how to maintain our databases sort of like our applications. A lot of us are probably familiar with application maintenance tasks. We can apply some of that thinking to our databases. Okay, so we're at the last one. I've got about 3 minutes left. If you haven't seen this term before, I liked this term, and I wanted to use it as the last one that kind of brings together all of the items in this presentation. The term is mechanical sympathy. So mechanical sympathy is when you use a tool or a system with an understanding of how it operates best. And it was originally coined by a race car driver and referring to a race car. But on the AWS well-architected framework blog, or well-architected blog, they sort of used it to refer to different technology systems. And in this case, we're going to look at it with a database in mind. So the mistake here would be rejecting mechanical sympathy, not learning how the database works, and then not being able to play to its strengths and do less of where it's not as good. So in Postgres, using a lot of high churn designs where there's a lot of updates and deletes as part of your core design, that doesn't work as well with how tuples and MVCC and auto vacuum works. Overusing limited resources on our database instance, so CPU, memory, and IO from inefficient reads and writes. Inefficient generated queries, not restructuring those or kind of moving more to handcrafted queries from gems, some that I've seen that have caused trouble, JSON API resources, GraphQL, Ruby, ActiveAdmin. Allowing lazy loading and N+1s, and not preventing excessively long queries or excessively long idle transactions. Oops. So to fix some of that, I recommend trying to take control of your SQL. So in Active Record Relations, we can use 2SQL to inspect the generated SQL and then work on improvements. So that could be reducing, again, our columns that we're picking, any joins that can be removed, and adding more where filtering, more criteria, removing unnecessary ordering, things like that. And then we can look at our execution plans, and we can use the explain keyword in Active Record to do that if you're not aware. We can also replace our high update or delete churn designs with append mostly designs. So one example of that is the slotted counters pattern, and there's a nice Ruby gem for that. I've got an example of showing how to use that with rideshare to replace some counting. And then in Postgres, there's this type of update called a hot update, which we're not going to get into, but increasing our proportion of our updates as hot updates is a write path optimization. And then on the Rails side, we can prevent lazy loading by using the strict loading feature, which is relatively new. And if you're not using that, you could start by logging violations where you haven't enabled strict loading, which will raise exceptions, but you just logged violations. And then lastly, we can preserve our system stability by setting some limits. And this is going to be through different timeout parameters. So we can set max reasonable durations for our queries, our number of idle, or length of our idle transactions, and our number of connections. So on the top here, the top box is just showing enabling the log forming of strict loading. The second box is showing 2SQL on an Active Record query. And then the third box is showing explain with a couple arguments, analyze and buffers in Postgres, which will print out our execution plan and enable the buffers option. So if you look down into the execution plan, we can see that there were 3 buffers that were in the buffer cache, showing as shared hits. So our idea here is really to embrace mechanical sympathy. When you understand how a system is designed to be used, you can align with the design to gain optimal performance. So that's what I've got for you today. And again, you can get this presentation at the QR code or this bit.ly address. And thanks for your time today. I hope you enjoy the rest of RailsConf.